In this tutorial, we will be installing OpenSCAD, which is the 3D modeling software that we will be using to create 3D models. So we go to OpenSCAD.org. You scroll down and you click on Download OpenSCAD. That will download the installer file. Now I already have it downloaded right here. I'm just going to double click and run this. Install. It's a fairly lean program, so it installs pretty quickly. Now we're going to go ahead and run OpenSCAD. I actually created some models previously, but we'll just click New. And if you get some warnings, just don't worry about those. Click Close. So we see a window to the left and a window to the right. On the left we see this 1. This is actually a line number. So if I hit the Enter key, we see additional lines here. So the way that OpenSCAD works is that we basically type in lines of code and those lines of code are compiled into our 3D model. So we can kind of make adjustments to our code which describes 3D shapes, adding to our model, even subtracting, cutting pieces off of our model. We're using primitive geometric shapes. So OpenSCAD is a little bit unique in that we use code to define various shapes, kind of scale them, resize them, move them around, translate them, and certainly we can cut pieces off of them as well. So we're dealing with primitive shapes here, primitive geometric shapes. There are also more advanced ways of getting more complex shapes, as well as importing other models. You can also import other models, be it 3D models or even 2D models, into OpenSCAD for further manipulation. So let's just start out really basic. So the primitives that we can use in OpenSCAD, certainly one of them is a sphere. And the way that I tell OpenSCAD I want a sphere is I just type sphere, and then one of the parameters that we supply to this quote-unquote function is just the number 1. This tells OpenSCAD we want to create a sphere with radius 1 at the origin. So I'm actually going to turn on our grid here, our X, Y, and Z coordinate system. So I'm holding the left mouse button. That kind of allows me to move the view around the camera view. So holding the left mouse button and moving the mouse around gives us this ability to move the view in 3D. Now if I hold the right mouse button and move the mouse, that kind of moves the camera around. Instead of rotating the camera, it actually moves the camera around, keeping our same view angle. So I typed in sphere and 1. Now we see here that we have parentheses around the 1, and that just kind of, this function here has one parameter that we supply to it. So we say sphere open parenthesis 1 close parenthesis semicolon. Now let's hit the F5 button. That will refresh our code, basically take our code and create the model that we were describing from our code. So I press F5 and there's our sphere in the middle. I can zoom into this by using the wheel on the mouse. So I'm just kind of translating over, kind of moving, getting a closer view using the wheel on the mouse. Now we see that it's a sphere, but it's not very detailed. We can see the facets quite readily. So one thing that we can do to make this a more detailed sphere is if I go back to my code here, I'm just going to move this sphere code down a couple of lines. Then I type $FN equals 40 semicolon. Now this is going to say the facet number. It's going to increase it to 40. So I hit F5 and we see it just became a lot more detailed. You just see tons more facets in our sphere. We can get even more detailed if we want. We can do, let's say, 100 facets, hit F5 to refresh, and it gets even more detailed. Now this is great for our final build of our model, but the more facets that we add to our model, the choppier that it will be when we actually are trying to build our model. So for now, you can just keep this at a low number. 30 to 40, at least on a mid-range computer, will work fine. So I just type in 30. I press F5. So this actually is what we term a variable, and this is a special variable. This $FN. This is a special variable that defines like I said, the facet number of all the geometric shapes in our in our OpenSCAD project. So sphere 1, so let's say I want to have a sphere of radius 2. I just type sphere 2, hit F5, and we see our sphere got larger. And we can see here too on our grid, the spacing is here, sphere of radius 2. So we go from the origin 0, 1, 2. So that indeed is a sphere with radius 2. And each of these, the units of measure in OpenSCAD, each of these units of measure are actually millimeters. So this is actually a sphere of radius 2 millimeters. We can also, in our code, document what we're actually doing by using coding comment notation. Now this is standard for the C programming language. So you can type // and then you can type comments here. Now these comments, everything that's after these 4 slashes is a comment, so it doesn't affect our code. So we can type whatever we want after these 2 slashes. We see it's highlighted, it's kind of in a greenish text, and that is basically indicating that this is just a comment line. It doesn't matter it doesn't matter what we type in that. Though if we go to the next line and start typing, we see that it's in black. So that would be a new line of code. Let's say I just press F5, we're going to get an error. It says compile error. That's because this isn't a valid line of code. So I'm just going to delete that. I'm going to actually document what we just did here. So this is a sphere of radius 2 millimeters. It's just kind of handy to document what we're actually doing here. So we have a sphere here. What can also be handy too is this text kind of starts out a little bit large. You can reduce the size of the text by holding the control key and pressing the minus button. So hold control, press the minus button a couple of times just to make the text a little bit smaller so we can get more on a single line. So we have a sphere here. It would be nice to do some more with this sphere, add additional primitive shapes. A good starting point is to make a chess pawn, just kind of a chess model, chess pawn model. It's kind of an easy type of 3D model to make. So when we think of a chess pawn, we have kind of a cylindrical base, kind of a cone in the middle, and then of course the sphere on top for the head of the pawn. So what I want to do in this case now, well, first of all, 2 millimeters is kind of a small head of a pawn. Kind of a more of a reasonable size of a pawn might be 5 millimeters. So I'm just going to change this 2 to a 5. I'm going to update my comment as well. Press F5. That's kind of more of a reasonable size for a pawn. Now what I want to do in this case is I want the base of the pawn to be kind of near the origin at the XY plane here. We have the Z axis here and the XY plane. So what I'm going to do is I'm going to create a cylinder. So I'm going to type cylinder, and then our parameters for the cylinder are the radius of the cylinder. So R equals to, we'll say 8 millimeters, comma, space, and H was the height of the cylinder. We'll say maybe 2 millimeters. So radius 8 millimeters, height 2 millimeters. Have to close it with a parenthesis and then a semicolon to end the line of code. I'm also going to put a comment in here as well, base of pawn. And I hit F5. Now we see that we just inserted this cylinder here, the base of the pawn, which is good, but we see now that the head of the pawn is way too low. It's in the base of our pawn here. So we want to translate that sphere upward. So another operation, an operation that we can perform on this sphere is to translate it upward. So we type in translate, and we need to translate it supplying 3 parameters. So the parameters that we're supplying are the translation in the x-axis, the y-axis, and the z-axis. So you can see this sphere, this head of the pawn, is right on the origin. The x, y, z coordinate is 0, 0, 0, right in the origin here. So what we want to do is we want to translate it up. We want to translate it in the positive z-axis direction. So we're not going to translate it in the x-axis, so we type 0 there. We're not going to translate it in the y-axis, so we type 0 there. Now, number of millimeters up that we're going to take this head of this pawn, we'll say, I don't know, maybe 8. So this is going to translate it up 8 millimeters. Now you see I have a parenthesis and then an opening square bracket, 0, comma, 0, comma, 8, closing square bracket, closing parenthesis. Now you might think, well, don't you want to have a semicolon there? You actually don't in this case. In this case, this translate line is only affecting the next line. So in this case, we don't have a semicolon. Another thing that we can do, and this is kind of standard in blocks of code when you're coding, is to enclose it with braces. So you hold the shift key, and the braces are when you hold the shift key and press the square brackets. So what I just did here is that this is an opening brace and a closing brace. And you see when you move the mouse, when you click next to the opening and closing brace, it kind of highlights in green the opening and closing of this code block. So this tells us translate everything in this block of code up 8 millimeters in the positive Z direction. So now that I've done that, I press the F5 key, and that translates the head of the pawn up. Now, 8 millimeters certainly wasn't enough. Maybe let's try 16. Press F5. Maybe a little bit more than that. We'll go, I don't know, maybe 20. That seems about right. Maybe the head of this pawn is just a little bit too large. We'll go maybe a 4 millimeter radius. It looks about right. So, like I said, you can have an opening and closing brace. That's kind of how I like to do it. And then I press Tab just to kind of tell me that this is the block of code, an additional block of code between these this opening brace and this closing brace. I just press Tab just to kind of indent it out to make it easier to read. And of course, an alternative to that, if you just have one line of code you want to translate, you don't need the braces. You can just go like that, as long as there's no parentheses there. Because if you have a parenthesis there, I'll put one there and press F5 to refresh our model. You see what it's not translating anything. It's just kind of doing nothing there, and then it's just putting the sphere back at the origin, the XYZ000 origin. So we want to. I like having braces. It just kind of makes things a little bit easier to read. So change it that way. Press F5. There goes the head of the pawn up again. Now on this pawn, the next shape that we want to insert into it is a cone. Now you don't really specify cones. Cones are kind of just specialized cylinders. So I'm just going to highlight this line of code here for this cylinder. Press Control C for copy. Go a couple lines down. Press Control V to paste it. I'm just going to reuse this line of code. So a specialized type of cylinder is kind of a conic cylinder where we specify two different radii. So we have radius 1 is, we'll say radius 1 is 7 millimeters, and then radius 2 is equal to, we'll say 2 millimeters. So I have r equals 7, comma, r2 equals 2, comma, a height of 2. Now this height, we're going to want this height to be a little bit higher than that. We'll just kind of tentatively say 16 and press F5 to refresh. So there's our conic cylinder right there. Another kind of neat feature in OpenSCAD is just for the sake of building things piece by piece, we can get an individual view of one of these primitive shapes at a time just by going to the beginning part of that line of code. If we press Shift 1 to put an exclamation mark there, and we press F5, then what it's going to do is it's only going to render that single shape. So in this case, it's only rendering this one line of code right here. So we see that cylinder, just to kind of give us a better idea of where it's at. Now you see here that the cylinder is right at the, it's kind of touching the XY plane here. We want to kind of shift it upward a little bit, just for the sake of kind of spacing things out. So I'm going to, again, copy this line of code here just for less typing. So I selected this line of code, hit Control C, I go down to here, press Control V to paste it. I'm also going to indent right there just to make it easier to read. So we're going to translate. Now we don't want to translate it 20 millimeters up. We want to actually translate it 2 because the thickness of this base cylinder is 2 millimeters. So I'm just going to go translate it up 2 millimeters in the Z-axis. I'm going to press F5. And that indeed took the middle portion of our pawn and moved it up. Now this cone is a little bit thick, so I'm just going to tweak our radius our radii values here. So I'm going to go radius maybe 6 for the base, and 2 seem, well, maybe let's go maybe 1.5 millimeters and hit F5. That looks a little bit more reasonable. And so this kind of is our a good kind of representation of a pawn. There are other things we can do to make this look a little bit more like a pawn as well. I mean, because we have some kind of hard edges, kind of hard shapes right there and there. A pawn usually has, you know, kind of an indentation out just under the head. Down here it might be a little bit more curved. Now, there are a few different ways of achieving this look, but one easy way of achieving this look is to take another sphere and kind of squash it in the z-axis, just to kind of make it more of like a disc, kind of like a curved disc. So what we can do is we can take, I'm just going to highlight this block of code, hit Control C, and then Control V. So I basically just made a copy of that sphere. Press F5. Now it actually rendered right over the other sphere. So I'm going to actually translate it down. Instead of going 20 units up, I'm going to go maybe 17 units up. So there it is right there. Maybe go a little bit lower. Let's try maybe 16. Okay. So what I want to do to this second sphere is I want to squash it, scale it down in the z-axis. So another operation that we can apply is scale. So I type scale, opening parenthesis, opening square bracket. So in the x coordinate, in the x-axis, I'm just going to scale it at 100%. So just type 1. In the y coordinate, I'm going to go again 100%. So just type 1. And in the z coordinate, I want to maybe scale it down by half. So I go 0.5 for half, closing square bracket, closing parenthesis. And again, I'm going to use braces just to kind of indicate, to make it a little more readable. So I have an opening brace, I indent this block, closing brace for the scale. So the scale function is here, the translate function is here. So what actually happens is we create the sphere here. This gets applied to it first. So we take that sphere, which starts at the origin, move it up 16 millimeters. So here it is sitting up here, 16 millimeters. And then once it's up there, we scale it down. So it's going to take it right there. It's going to squash it in the z-axis. Now, actually, I did actually get that wrong. We want to actually scale it first. So while it's down here at the origin, that's when we want to scale it down, and then we want to move it up. So I'm just going to reverse the order in which this happens. So actually, I'll press F5 now, refresh it, and see what happens. So we see, where's our sphere? It kind of disappeared. Whenever that happens, you could just press that exclamation mark and hit F5. So there's our sphere right there. So what this actually did was it created the sphere at the origin. We moved it up 16 units, and then we squashed it down by 50%. But it's not really where we expect it to be. What we want to do is we want to Control X, cut, Control V, paste, Control X, cut, Control V, paste. So I just kind of reversed the order of operations here. So what's going to happen now is we're going to take our sphere with radius 4 at the origin right there. We're going to squash it down in the z-axis by 50%. Then we're going to move it up 16 units. So we do this first, we do this second, and then we do this last. So it kind of just builds out from the center here. So I'm just going to get rid of that exclamation mark, press F5. So that's kind of more what we're looking for here. So again, we start at the origin, we squashed it down by 50% in the z-axis. That kind of just squashed it down, make it more like a disc, and then we translated it up 16 units, 16 millimeters. So let's try maybe 15 millimeters. I kind of want to get it right under that, right under the head of the pawn there. And it is kind of a large radius there for that sphere. So maybe if we go, I don't know, 3.5 millimeters, that looks a little bit better there. So the next thing we want to do is maybe put in more of a curved base here. And we can actually do that the same way as here. We can use a squashed sphere to kind of round this out a little bit more. So I'm just going to highlight this line of code since it's kind of convenient. It's in the same, it's right along the z-axis right there. So I'm going to highlight all this code, Press Control C for copy, go down a couple lines, Control V, paste it. And then instead of going 15 units up after scaling it, let's actually go up maybe only 2 millimeters. And we want this sphere to be a larger radius. So the base here is, this cylinder is radius 8. So we want to have this sphere also be radius 8, I'm thinking. So we change that to 8, press F5. And there we go. We kind of rounded it out more. Now maybe we want to squash it down a little bit more. Maybe squash it down to a third approximately. And that looks good right there. Though we kind of see right at the bottom here, if we're looking right down the XY plane here, we see this kind of bump at the bottom. Now that bump is actually that sphere. So there's the sphere, squashed sphere right there. What we want to do is we want to actually cut that little bit off. And that's where we can kind of get into the difference function. So we can add primitive shapes, but we can also cut out primitive shapes from our model as well. So that's what our model looks like. I'm going to actually use a cube to cut this little bit off. So I'm going to basically specify a cube sitting right under the XY axis, and I'm going to take this full shape here and I'm going to just lop off everything that's below the XY plane with a negative Z value. So it's going to lop off this little bit right there. So what I want to do first is I want to take a union, so just a union of all these shapes. We're just going to consider that one unit. And that union of all these shapes, which will be one unit, we're just going to cut off a second portion, which will be the cube. So I need to specify all these shapes thus far as one unit by using the union descriptor here. So we type union, open parenthesis, close parenthesis, opening brace. Then I go down to the bottom of the code and have a closing brace. Now again, I mean, it's a little bit tedious, but just to add all these tabs to kind of make it a little more readable. But I like doing this just to make it again more readable. I can tell what block of code I'm working on, what level. So this union function, it starts from this opening brace and closing brace. All this does is it says treat all of these different shapes now as one unit. So that allows us to then use the difference function. So I type difference, opening parenthesis, close parenthesis, opening brace. Now this difference function, it expects two portions. It expects what we start with and what we're subtracting from it. So what we're starting with is this union here, this shape. These kind of combination of shapes will be kind of the A portion. We want to subtract from it a B portion. So a starting portion, and then the second portion is what we're subtracting from this shape. So what we want to subtract from this combination of geometric shapes is a cube. So I type in here cube, opening parenthesis, opening square bracket. Now if we take a look at our shape thus far, so we have a radius of 8, so this must be our 10 hash mark. We'll say in the x coordinate and the y coordinate, we want it to be maybe a cube, 20 by 20, and then we'll go down maybe 3 units. So we go 20, 20, 5, closing square bracket, closing parenthesis, semicolon, and we press F5. Now we have an error there because we have an opening brace there but no closing brace. So I add a closing brace for this difference operation. So that brace matches with that brace. In this union function we have that brace matching with that brace, and everything between these braces is treated as one unit. So now if I press F5, I'm actually going to press... Okay, yeah, so what's actually happening here is our cube is actually right here. Now if I put an exclamation mark at this cube here, we'll just see only the cube. So there's the cube right there. Now it's not a perfect cube, but we're specifying an X, Y, and a Z value for this shape here. it's still considered a cube as far as OpenSCAD is concerned. So what we actually want to do is we want to perhaps center this cube shape at the origin. So what we can actually supply to this cube function is we type comma, we type center equals true. So that's going to put this cube right at the origin. So if I press F5, there it goes right at the origin. Now you see it is indeed the center of the cube is at the origin. So we actually want to translate it down a little bit. I'm actually going to make this cube 6 units in the z-axis, and then we want to then translate it down by 3 units so it's just under the XY plane. So I'm going to, again, just because I'm lazy here, Control C, Control V, and I want to make sure my braces add up here. So we're going to translate this cube down 3 units. Now that's going because the cube is 6 units in the z-axis, and it's centered on the origin, if we put it down 3 units, if we translate it down 3 units in the z coordinate, we press F5. Let me see here. We press F5. I'm going to actually put the exclamation mark on the translate function so we see. So there it is right there. It is below. It is just below the XY axis. It basically is telling us what we want to cut off from the other shape. So if I get rid of the exclamation mark, now it's going to actually take the union of that pawn shape that we created initially, and then it's going to cut off that cube portion of it. So if I press F5, that's indeed what happened. So we can kind of see there in green what it is actually cut off. So again, if I put a exclamation mark by the union, we're just going to see this union right here. Just that's going to be rendered. So if I press F5, now again we see that little portion of that sphere right there, and then we're just going to cut off this portion from it. We're going to cut that portion off from it, and then we get our pawn shape right there. So again, we have a cylinder for the base. We have a sphere that has been scaled down in the z-axis by 1/3 with radius 8. So that sphere radius 8, scale it down by 1/3 in the z-axis, translate it up by 2 millimeters, and that kind of is our curved base. We then have a cylinder here, which is kind of more of a cone. We have a radius of 6 right there, and then we have a radius of 1.5 right there, forming kind of the mid portion of the pawn. Just to kind of stylize the pawn a little bit, we have this sphere right there squashed down in the z-axis by half, and then translated up just to be under the head of the pawn. And then of course we have the pawn head itself there, radius 4, and translated up 20 millimeters. So I kind of spoke of the number of facets. If we increase this down to, say, I don't know, 80, press F5, we see how it got really smooth. Now when we actually build our 3D model and then for printing it out, we'll want to actually print it out. We want to create our final model in lots of detail so that our printer will pick up on all the details. But yeah, for a shape this large, you know, this number of facets will be plenty. I mean, our printers have decent resolution, but not crazy resolution, so this would probably be fine. So I've been pressing F5 to refresh my model as I've been making changes to it on the code here. But if you want to actually build the model, you actually have to press F6, and that's going to fully render it. So I press F6. And then what's actually happening now is it's building the model. It's going to appear here once it's done rendering. It can take a little bit of time to render the model, but once it's rendered, it will appear, and then we can actually export it as an STL file. Now once it's an STL file, we can then open that STL file in our printer software, our 3D printer software, and then tell our printer to go ahead and print it. Alright, so we see it did finally render. So what we want to do is we want to save our progress, of course, in case something happens to the computer. We don't want to lose our work thus far. So we can go to File, Save, And it's going to default to the OpenSCAD folder. You might want to save it to perhaps your desktop, your My Documents, or if you're on a network computer, your H drive. I'm just going to save it to my desktop. I'm going to call this pawn.scad is the file extension for OpenSCAD projects. So I go ahead and click Save, and we can see desktop here. There's my pawn model, pawn.scad. So that the SCAD file is only for OpenSCAD. If we want to take this model and print it off on a 3D printer, we want to export it as a more standard 3D model format. That's the STL format. So because I pressed F6 and rendered this model, I can now press this STL button. If I click on that, it's going to ask me where I want to export pawn.stl, which is the model, the more standard format model that can be opened up in 3D printing software and then printed out on a printer, as well as exported to other software if you want to manipulate it further, or even if you have other STL models, you can import them into OpenSCAD. You can also, I believe you can also import in other OpenSCAD files, just the .scad file format. But I'm just going to export this as pawn.stl right on my desktop and click Save. And it is exporting to that STL format. And if I minimize OpenSCAD, there it is right there. Now I actually have the Affinia software installed on my computer here. So if I double click on this STL file, my computer recognizes it and associates it with the Affinia 3D printing software. So if I double click on that, he's going to open up the Affinia 3D software and load the pawn model right in there. So we can kind of zoom in and see that's how it would print off on the printer there. We've exported to STL so we can print it off on a 3D printer, and we also have the OpenSCAD file saved there. So from here you could make further modifications to it, save it as different versions. You might want to have pawn version 1, version 2, version 3. What you're doing is you're incrementally developing this 3D shape. That way you can kind of make changes to it and go back to a previous version if you don't like the changes that you made to it. As well as kind of spin off other models from a model you've already created. So that's kind of one of the powerful portions of this. You don't have to actually open up, create a new model, kind of drag around like you would in SketchUp. You can just kind of reuse your code in other models, kind of just very finely tweak it numerically as opposed to clicking and dragging with a mouse. That's really the power of OpenSCAD in numerically describing your shape. In many ways it can make it very easy to tweak various aspects of it very precisely, as opposed to kind of messing around with the mouse and kind of zooming in and tweaking everything around in 3 dimensions, just specifying in code as the alternative. So that's just kind of a quick look at OpenSCAD. We may get into other more complex examples, but this is just a good starting point, adding various primitive shapes here. So we covered our sphere, our cylinder, our cylinders creating cones, as well as scaling primitives. We kind of also looked at the cube there for the purpose of subtracting the overlapping kind of bottom portion of that scaled down sphere. As well as the difference operator, as well as the union operator too, the union function, I should say, difference function and the union function. The union function taking multiple lines of code and kind of just making one big union out of it, whereas the difference function expects two basic unions. So we have this first union here, and the second union is just one more or less shape. So this is our A minus our B equals this. So again, that's just kind of a quick look at OpenSCAD, and we'll get into further examples that are more complex.